Okay, so how do we complete the square? I'm going to do some basic examples, and then I'm going to do a little bit more difficult examples. Well, one more difficult example. So for the thing that you want to, your goal. So this is called, it's called complete the square. This is your key here. So my end goal is to get something squared equals something. That is what I want. But the issue here is that this is not a perfect square trinomial. Perfect square trinomial where you have, let's just say, x plus a squared is going to equal x squared plus 2a x plus a squared. I know this because if I took this, if I did x plus a times x plus a and I FOILed it out, I would get x squared plus xa, or ax technically, ax plus a squared, and this becomes 2ax, and that's where my 2a comes from, up here. Okay, I'm going to erase this down here because I want to, if I have something like x plus 2, or let's do a different example. Let's do x plus 3 squared, right? I would get x squared plus 3x plus 3x if we did the whole FOIL shebang, or we would just get x squared plus 6x plus 9, where 6 is double 3 and 9 is it squared. 3 times 3. Okay, so that's the key here, is that whatever a is, this is double here and this is squared here. So what that means is that this is not a perfect square trinomial. I know it's not a perfect square trinomial because this is a 12 and this is a -5, right? First of all, perfect square trinomial always has, always has a positive c value. So let's talk about how to do this. The first thing I want to do is I want to isolate my variables. So I'm going to get rid of this. So I'm going to do plus 5 and I'm going to bring this over here. Okay, ooh, that's right. Let me move this down. And then I'm going to have x squared plus 12x equals 5, because we just moved that 5 over. I'm actually going to put this as equals 5 a little bit over because I'm going to use this space right here. Now the question is, how do I make this right here a perfect square trinomial? Well, if this is going to be double a, that means it's going to end up being a is equal to 6, right? Or 12 divided by 2 is equal to 6. 12 over 2 is equal to 6. So that means right here needs to be 6 squared, which is plus 36. And that means if I do it here, I have to do it here, plus 36. And so what I end up getting is, I'm going to write it out, x squared plus 12x plus 36 equals 5 plus 36, which is 41. And then this right here, we just did it over here, is x plus 6, that a value that we have. So this is x plus 6 squared equals 41. Goal met. Let's do one more where the a value is 1. Now, this is the same concept, except it's all jumbled up, okay? So what I'm going to do, again, we want to isolate our variables in standard form. So I'm going to bring this over because I want a positive a value. It makes it a lot easier, and I'm going to bring these together. So I'm really going to bring this over here, and I'll bring that 4 over here. Okay? So what that's going to look like is I'm going to add x squared to both sides, and I'm going to subtract 4 from both sides. And so when I do that, let's move this down. So when I do that, I'm going to get 12 minus 4. This goes away, and this goes away. So 12 minus 4 is going to be 8 equals, and then x squared plus 10x. Now we can complete the square. Now we take this, 10 over 2 is equal to 5, and then 5, this is plus 5 squared, right, which is 25. So I'm going to add 25 to both sides. And so I get 8 plus 25, which is 33, and that equals x squared plus 10x plus 25. And this is my perfect square trinomial. We just completed, this part right here is completing the square. And so we get 33 is equal to x plus 5 squared. And then you're done. That's just the completing the square portion of it. And so what happens if there is a coefficient in front of the term? Okay, so something like this. So the first step is still the same. Isolate your variables. So I'm going to isolate these together, and I'm going to bring over this. I'm going to zoom in a little bit. So I'm going to bring over, I'm going to subtract that 30, get rid of it, send it off to college for a little bit. So I get 3x squared minus 18x equals negative 30. And now I have to factor out this a value right here. Not the GCF technically, right? Because the GCF here is 3x, but I just need to factor out a, whatever a is. If a is 2, you're taking out 2. If a is 7, you're taking out 7, even if it does not divide out evenly. So you have 3, take out that 3, and so I have x squared minus 6x. I'm actually going to move this down a little bit. Okay, so I'm a little bit of a stickler with the lines, obviously. Equals negative 30. I kept the space here because we're going to end up completing the square. So this is where a lot of people mess up. So I'm going to still complete the square over here. I'm completing this square right here. And so it's x squared minus 6x, right? Plus what? 2, which is 3. And over here, I'm going to put 3 squared, which is 9. Sorry about that. Okay? But, big but. Big but. This 9 is technically not a 9. This 9 is technically a 3 times 9. This, hold on, by the distributive property is a 3 times a 9. So this 9 right here is really a 27. So I'm going to put plus 27 here. Okay, let's see. I don't know if I could highlight overlap things. Kind of. This and this are the same thing. Okay, and so now I have 3 times x squared minus 6x plus 9 equals, and then negative 30 plus 27 is negative 3. Okay, and so I have 3x minus 3, right? This 3 right here, squared. It's half of this, and the square root of this is negative 3. Well, yeah. And then equals negative 3. And then with conics, you're going to have to divide by that 3 eventually. Right? But as far as completing the square goes, let's just skip that for now. As far as completing the square goes, this is really what you need.